Hi, good morning. Hey, I always say good morning. I don't know, you could be watching me in the afternoon. Hi, how are you? Hey, before we get started today, it's Wednesday, April 1st. And before we get started, I want to give a little recognition, a little shout out to David, because I got an email yesterday from David and he sent me a video of him doing the Alka-Seltzer experiment. David, I enjoyed that so much. You did such a great job. Keep it up. If you guys end up doing any of the labs that I send you, I would love to see them. I miss you all so much. I guess it's times like this when we didn't even realize, you know, I miss you all and I miss school. I miss seeing you. I miss interacting with you and laughing with you and joking around, and I miss it. Even if you guys don't have anything to send me, videos or anything, send me an email. Let me know how you're doing. I miss you guys. Hope you all are doing well and staying safe. Okay, let's go ahead and get started for today, okay? Let me share my screen. And first things first, we need to take a look at your standards for today. The video today is going to be fairly short. I'm going to try and keep it underneath 5 minutes. We'll see how I go. But I wanted to show you, we're going to focus on the standard today for just developing models. And we have talked a lot about how it's important for you guys to learn how to use models, because scientists and engineers use models all the time to represent things that are either too small or too big, take too long, whatever, things that we can't see with the human eye, with just the naked eye. And it also helps us to figure out our own understanding about how things work. And so developing models are actually really important. And I wanted to show you the two standards for the chemistry unit so that you understand what exactly I'm looking for. So the first standard says develop models to describe the atomic composition of simple molecules. A simple molecule is just, just the arrangement of atoms. And you know how in Amplify we use circles with the symbol for the atom on it. That's all I'm asking you guys to do. Just use those simple models so that you can demonstrate your understanding of how the atomic structure works, and specifically look at the second one. Develop and use a model to describe how the total number of atoms does not change in a chemical reaction, and thus mass is conserved. Hang on one second. I had a frog in my throat. I had to cough. Okay, so if you guys remember, we've talked a lot about the conservation of mass, and that means whatever atoms we had to start with our reactants. After that chemical reaction has taken place, those same number of atoms are on the product side. No atoms go away and nothing new comes. We have to kind of keep track of those atoms. So I'm going to ask you guys to consider that for your assignment today too. Okay, so our objective today is the student will develop a model of a chemical reaction to demonstrate their understanding of the law of conservation of mass. And your homework, and yes, you have homework today, is chemical reactions, how the rest forms worksheet. Okay, so let's get in here and I'll show you. This is from Amplify, and I decided to go ahead and use the worksheet from Amplify because you guys are familiar with the iron pipes and the fertilizer. Now, yesterday, you all watched as I showed you a demonstration of how to use tin and other compounds, other household ingredients, vinegar and salt and hydrogen peroxide, to cause that chemical reaction for rust. I just wanted to keep it simple, and let's just focus on iron pipes and fertilizer. Okay, so all I'm going to ask you guys to do today is I want you to draw the iron pipes and the fertilizer before they changed into rust. And I want you to draw them so that you're modeling their atomic composition. Don't draw the macro scale. Don't draw a pipe and draw fertilizer. I want, what do those look like on the atomic level? And then draw what it looks like during that chemical reaction, and then what that looks like after, which is the rust. What does that look like on the atomic level? You're going to have a key right here, and here's my little reminder for you. In order to get full credit for this assignment, you need to do 100%. And so in order to show proficiency, I want to know that you understand that the same number of atoms that you had over here representing iron pipes, those are over here. And the same number of atoms that you had that represented the fertilizer, that's over here too. It's here, here, and here. They don't change because they don't just disappear, and we don't get them from something else either. So if you need to work on it again, I'll just return it back to you. Watch for an email from me. We'll communicate back and forth until you get 100%, okay? Let me show you something really quickly. I did a bad example for you because I want you to see what one looks like. I didn't want to do what we call an exemplar, which is a good example, because I don't want you to copy me. I want you guys, that's your standard. You've got to develop these models. And so I want you to go out on a limb. And some of you guys really struggle with this, and that's okay. You can do it. I know you can do it. If you have any questions, call me. Don't call me. You can email me and ask me specific questions, and I can help you out a little bit. But let me show you what a bad example would be. Sorry. So a bad example would be showing the macro scale, or hey, I'm going to draw a pipe and I'm going to draw some fertilizer. And then I'm going to put them together during the chemical reaction, and then boom, there's rust. That's a bad example because you're not showing me what is happening on the atomic level, what happens to those atoms. And remember, during a chemical reaction, the atoms will separate and rearrange. And so that's what I'm looking for. Okay. So why is this a bad example? First of all, don't draw macro scales. Second of all, the second and the first and second boxes are exactly the same, and it does not demonstrate that law of conservation of mass. So here's some tips. Draw the atoms themselves. They don't have to be right. I don't care what the actual correct formula is. We're not looking for that. Just draw an atom or a model of an atom for lead. Draw a model for an atom for fertilizer. Show me how they would rearrange during the change, and then what they would look like afterwards. And it's just your own explanation, okay? Oh, I have a typo down here. So show what happens to the atoms during that change, all right? Okay, let's move on to the next page. Whoops, reminder, here's your key concept. During a chemical reaction, atoms cannot be destroyed and they cannot be created. That's the law of the conservation of mass. And that's what I'm checking to make sure. So I will be counting your atoms to make sure you have the same number of atoms for each substance before, during, and after the chemical change. All right, if you have any questions, one other place you could always go is go back to Amplify. Remember how in the chemical reaction sims, they had the, I think it was lab A that you could go in and you can combine atoms. And so I did one real quick as an example. Here's an example. This is what they had chlorine look like, and each one of the sodium molecules looked like that. And then afterwards it looked like that. So use that same idea for a model if you'd like to create yours. All right. So here's what you're going to do. You're going to turn yours in to Schoology. And I put an arrow there. A lot of times you guys always ask me, I'm ready to turn it in, what's the name of the assignment? So I'm showing you the name of the assignment. It's Chemical Reactions, How the Rust Formed, and that's where you'll turn it in, okay? And I'll be giving you some feedback. Watch for feedback. If I need you to redo or reconsider something, I'll be emailing you, okay? All right? If you have any questions, please don't hesitate to email me and ask me specifically, okay? And I'm happy to help you guys with that. That's what I'm here for. Miss you all so much. Hope you all are well. Take care. Bye.